All right, let's move on to section 2 and get into limits. All right, so definition of limits. Okay, here's the definition of a limit. Okay. Suppose the function f is defined for all x near a except possibly at a. Okay, so there's some value you plug into the function and it's not defined there. Okay. If f of x is arbitrarily close to L, as close to L as we like, for all x sufficiently close but not equal to a, we write the limit as x approaches a of f of x equals L, and say the limit of f of x as x approaches a equals L. Okay, so what the limit is just what is the function approaching as x approaches a value. Okay, now when I say what is the function approaching, am I talking about x or am I talking about y? What is the function value? It is y. So what is the y? And that's important. What is the y? What is the y getting close to as x approaches something? All right, that is the limit. Okay. Now, we'll look at a graph here first. Okay, there we go. All right. So here's a graph. So we start out just by looking at graphs. Okay, first. All right. So it says use the graph of h in the figure to figure the following values or state that they do not exist. All right. So here's a graph. All right. X, y. Okay. So all we know is just this is h of x. This is a function. Okay. So first, what is h at 2? Okay. So what is h at 2 there? Okay, that's a hole there, but they've got that point right there. So if I want to say what is the function value when x is 2, that is actually going to be what? 5. All right, so this one is 5. Okay. All right, okay, so now do this one. All right, the limit as x approaches 2 of the function. So what is the y value getting close to as x gets close to 2? So as x's get closer and closer to 2, what's the y values doing? Well, when I'm right here, the y value is here. When I get here, the y value is here. When I get here, the y value is here. What is it getting close to as I approach 2? It is approaching 3, okay? Not 5, okay? So that's what you got to get straight. So the limit is what is it approaching as you approach the x, okay? So the limit as x approaches 2 would be 3, because that is what it is getting closer to, and we're going to see it has to do the same thing from both sides, but, okay, so that is going to be 3. Okay, questions? All right, the limit, okay, so what's the function value at 4? All right, 4 is here. What do we say about that? There's a hole there, right? There's nothing. So, does not exist. Right, so that does not exist. Okay. The limit as x approaches 4. Okay, so as x gets closer and closer to 4 from both directions, what is y getting close to? It's getting close to 1. Okay. The limit as x approaches 5. All right, 5 is right here. Notice it is defined there. So if it's defined there, what is x getting close to then at 5? Just getting close to 2. It is 2, right? All right. Questions about that? Now again, this is a big thing to remember right here, is that h of 2 is 5, but the limit as x approaches 2 is actually 3. So that's what you got to keep straight with the limits. All right. Okay, let's do one now where we have a table, and we don't want to do tables much. Okay, so we'll just do this one, and that'll be it. So, when you're trying to find a limit on a test, don't start plugging in values. Okay, so it says calculate f of x for each value of x in the following table, and then make a conjecture about the value of the limit. Okay, so notice it's the limit as x approaches 2 of that function. Well, what happens when I plug 2 in there? it's undefined. All right, there's a hole there, or it's not defined, or either asymptote. So, but what's it approaching there? All right, well, what you can do, all right, is this is just using a table. Take 1.9 is really close to 2, right? So plug 1.9 in for x, the top and the bottom, calculate it up. All right, if you put 1.9 in, you will get 3.9 for the function value. Okay? Put in 1.99. So 1.99 squared minus 4 divided by 1.99 minus 2, I get 3.99. Okay? When I put this one in, I get 3.999. Put that one in, I get 3.9999. Okay? Now that's from one side. Okay, now let's come from the other side. Okay, so if I'm at, let's do 2.001. If I put that in for x, I get 4.001. Okay. If I put that one in for x, I get 4.001. If I put this one in for x, I get 4.01. If I put that one in for x, I get, well, I should have went the other way, but anyway, that's fine. 4.1. Okay? So this one here, 2 would be right here, 2 would be right here. So what do you think what the function is, the limit of x as x approaches 2 of the function would be? You would think it would be 4. Okay? Now we will see how to know for sure it's 4. Okay? So we're just making a conjecture by looking at numbers. But it is 4, and we will see later why, a way that we can know analytically that it is 4 for sure. But anyway. All right, any questions about that? Only time we're going to do that. Don't ever do that again. Okay? So we don't, people always want to start plugging in values doing tables for limits. Don't do it. Okay? There's other ways. That's not the way to do it. Okay. All right. Let's go on. All right, so now he goes ahead and introduces one-sided limits, which is fine. All right, everybody, a lot of textbooks do it, introduce things differently. All right, so a one-sided limit. Okay, now, one-sided, what do you think one-sided means? Just coming from one side. Okay, so, and I don't know if you can see this very well, but that is the limit as x approaches a. If there's a plus sign, like an exponent up here, that would mean what is the limit as x approaches a from the right? Okay? Or from the positive direction, which is the right. Okay? The limit as x approaches a, if that's a negative sign, that would mean from the negative side, which is the left. All right? Of f of x. So again, when you're finding the limit, you're actually finding what value? An x or a y value? You're finding a y value. All right, so what's the y doing as x approaches something from the right, or what's the y value when x approaches something from the left? Okay? All right, so one, right side limit. Suppose f is defined for all x near a with x greater than a. If f of x is arbitrarily close to L, for all x sufficiently close to a with x greater than a, we write that and say the limit of f of x as x approaches a from the right equals L. Okay, so it's the same thing we talked about a while ago, except you're only looking at one side. Okay, so you've got the limit from the left, you've got the limit from the right. Okay, and that leads to Theorem 2.1 here, which is an important theorem. Okay, so it says assume f is defined for all x near a except possibly at a, so it doesn't have to be defined at a. Then the limit as x approaches a of f of x equals L. Now, notice this is not a right or left. This means the limit. So the actual limit exists is equal to L if and only if. Okay, now what is if and only if? That means it's true both directions. If this is true, then that means the limit from the right and the limit from the left has to be the same. Or you can say, since it's if and only if, that if the limit from the left, the right, and the limit from the left are both the same, then you can conclude that the limit as x approaches a is equal to the limit as well. Okay. So in other words, for a limit to exist, it has to approach, that y value has to approach the same thing from both sides. If it does not, the limit does not exist. Okay. Now we can say the right-sided limit is something, the left-sided limit is something. But for the limit to exist, the y value has to approach the same y value from both sides. Okay? There we go. Use the graph of f in the figure to find the following values or state that they do not exist. If a limit does not exist, explain why. All right, so first, f of 1. Yes. Is that good? Is that better? All right. Let me try to wipe that just a second, see if that'll help. Nope. Well. Okay, f of 1. What is the function value at 1 when x is 1? It's x. X is right there. All right. That point there is what's defined, and that is at 0. So f of 1 is 0, okay? Okay. Now, what is the limit as x approaches 1 from the left? Okay. So here's 1, okay? So as x goes this way, what's the y values doing? Well, here's the y values here. What are they approaching as x approaches 1? They're approaching this one right here. Everybody follow that? All right, what about as x approaches 1 from the right? Okay, here's 1. All right, so as my x's are coming this way toward that, here's my y values here. They're going toward what? 0. From the right, that limit is 0. Okay. Now, what is the limit as x approaches 1 of the function? What's true about the limit? What's the definition? Okay. Why does it not exist? It's not approaching the same thing from both sides. It's got to approach the same thing from both sides for the limit to exist. Okay. Now, the left-handed limit exists, the right-handed one does, but they're not the same. It's approaching 1 from the left and 0 from the right. It's not approaching the same thing. So this does not exist. Okay? Very important concept. Okay? Questions about that? Okay. Okay, so f at 1. What is the function value when x is 1? 3. So that should be 3. All right? The limit as x approaches 1 from the left. All right, so as I'm going this way toward 1, what is it doing from the left? What's it approaching? It's approaching 2. All right, so see the y values here are getting closer and closer to 2 as x gets closer and closer to 1. Okay? From the right side, what's it approaching as it approaches 1? It's also approaching 2. Okay? So, what is the limit as x approaches 1? Now, this is one people miss on tests a lot. Okay, so what would you say the limit as x approaches 1 is of f of x? 2. Whatever it is approaching from both sides. It is not 3. Half of you will put 3 on the test. Okay, but that's not right. Okay, so whatever it's approaching from both sides, that's what the limit is. Now, f of 1 is 3 on this function, but the limit as x approaches 1 is going to be 2. Okay? F of 3, same thing there is 2. Right? The limit as f approaches 3 from the left, as you're going this way toward 3, what is the y value approaching? It is approaching 4. Okay? From the right, what's it approaching from the right? at 3? Approaching 1. Okay. So from the left, it's approaching 4. From the right, it's approaching 1. So what would I say about the limit as x approaches 3? Does not exist because it's not approaching the same number. Okay. F at 2, well, that's right there. Okay, that's definitely 3. Okay. The limit as it approaches 2 from the left is 3. From the right is 3. So the limit as x approaches 2 is 3. Okay. So what you'll see is that if it's defined and it's a continuous function, it's just always that value. If you can plug it in. All right. Any questions about that? Okay. There's another one of those. I'm going to skip it on here. It's the same idea. You're just looking at graphs, and you get to practice that on the homework a bit. So same thing there. All right. Let's go to this next thing here then. All right, sketch a graph of f and use it to make a conjecture about the values of f of a. All right, now, in the next section, we'll do these. I really kind of want to go ahead and look at these a little bit analytically now. As x approaches 5 of the function. All right, they said a was 5. Okay, so of course that's the value where it's undefined. All right, so they said think about it graphically. Okay. So, looking at that function, anybody notice anything about that as far as the graph goes? If you think about the graph of this, what would that look like? Anybody see anything on there? Yes, yes. The top is the difference of squares, and notice if you factor it, you get x plus 5, x minus 5 over x minus 5, and then what happens? Those will cancel, divide out, so you get f of x equals x plus 5. What is that the graph of? Just a line, all right? Except at 5. At 5, what's going to be on the graph at 5? There's going to be a hole in the graph, right? So your graph would look something like this. You'd have a y-intercept at 5. All right, and then you just go up 1 over 1 till you get to 5. All right, which would put it at what value? 1, 2, 3, 4, 5. That would go up to 10. And there'd be a hole right there. Sorry, this marker's about out. See if I've got another one. Okay, so you got a line with a hole there. So, knowing what we know about functions now, what would be the limit as x approaches 5 of this? 10, because it is approaching, the y value is approaching 10 as you go toward 5. So that limit would be 10. All right, everybody follow that? Okay. Now that's exactly what we're going to do in the next section. Some is how to do these analytically, but that's what we've got. Now the next one, I went and threw it in there. F of x equals x minus 100 over square root x minus 10. Okay, and we want to know what is this when what's the limit when a is equal to 100. So we want to know the limit as x approaches 100 of the function. Well, guess what? If I put 100 in the bottom, that gives me 0 in the bottom. All right, so what do we have? All right, so look at this one. Now, I threw this one in. When we do these in the next section, we'll probably multiply the top and bottom by the conjugate and that kind of thing. But, and you do this one kind of like we did the last one. the top is a difference, okay? It's really not, no, they're not squares, but how do I come up with over here x plus 5, x minus 5? I'm just taking the square root of x squared to get x. The square root of 25 is 5, right? So can I do the same thing here? All right, if I've got a difference, so x minus 100 really is the same thing as the square root of x minus the square root of 100, which is what? 10 times square root of x plus 10. All right, is that not the same thing? Okay, and then now what happens? This cancels. So I get f of x equals root x plus 10. Okay, so that graphically then would just be the square root function up 10. Then if I go over here to 100, what if I plug 100 into there? What do I get? Root 100 plus 10 would be 20. Is that right? Yeah. So it would look something like this. Okay. Does that make sense? So what is the limit as x approaches 100 then? It is approaching 20. Right, from both sides. Okay, any questions about that? Okay. Now the next one on there is very similar. I'm not going to do it. We just got 5 minutes. Let's do these second two here. All right, I'm going to graph it. Okay, so let's do the first one here. I've got parentheses e to the 2x minus 2x minus 1 divided by x squared. Okay, there we go. Okay, so notice notice on here, when I hit this on decimal, it shows me what the point is. So notice when I get up here to where x is 0, I can do it. Let's see, I'm not up there yet. There it goes. What does it say it is when at 0? It is undefined because 0 makes the bottom. But what does it look like? Looks like the limit is as x approaches 0. What is the y value as x approaches 0? 2. So it looks like from looking at the graph that as x approaches 0, the function value is 2. Okay. Any questions about that? Okay, the other one, let's see, is see if I can just add it in here. All right, there we go. So 1 minus cosine 2x minus 2 over x minus 1 squared. All right, that's the graph. Okay, so we want to know as x approaches 1. All right, well, now again, notice if I go around here, when I get to 1, there it is. 1 is undefined. Okay, what does it look like? What does it look like the limit is, though, as x approaches 1? What's the limit as x approaches 1? 2. All right, so as x approaches 1 right here, the function value here is approaching 2. Okay. Now, again, very important, you know that you're looking for y. Okay. Because you're going to be thinking all over the place if you don't. So that's what, just try to get that straight. So, all right, any questions? Okay. All right, so I'll see you Monday. Try to have through 2-2 worked. You should be able to do the rest of 2-2. I'll do a little more next time, just a little bit before we move on. But try to get caught up on the homework. If you're not, I hadn't looked lately. But see anything else I want to tell you? I guess that's it. So I'll see you Monday. All right, so we'll finish up 2-2 here. All right, now this one was on the quiz, okay, and this is called a greatest integer function, okay. Now and the notation they use with this text is a little different than the other notation. They call this a floor function, okay. So for any real number x, the floor function or greatest integer function, and they use this notation, okay. Now if you notice on the paper that I had given you, this was the notation for it, and in a lot of text you'll see it like this. Okay, it's the same. So that's the same thing as this. Okay. This greatest integer function is the greatest integer less than or equal to x. Okay, so it's the greatest integer less than or equal to x. So an integer, what is an integer? Or what is not an integer?
Integer is any whole number, isn't it?
Any whole number that is positive or negative. So it is not fractions, okay? So, or decimals. So integers are just positive and negative whole numbers. So on the function here, notice if everything between here and here on the x, like if I have 0.5 or a half, the greatest integer less than or equal to 0.5 is actually 0. So everything from here to here is going to be 0 until I get to 1. Then when I get to 1, what's the greatest integer less than or equal to 1? It would be 1. Then it jumps up to there. And everything between 1 and 2, that's a decimal or a fraction, the greatest integer less than or equal to that would actually be 1. Till you get to 2, then it jumps up. Okay, so it keeps jumping as you go up. So that's how the function works, okay? All right, so let's see if we can answer these questions here. All right, so the A part says, compute the limit as x approaches -1 from the left. All right, so as we approach -1 from the left, what is the limit as we approach -1 from the left? It is -2. All right. And then the limit as x approaches -1 from the right. So as I go this way, what is it approaching? What's the y value here? That's 0. What's that one? -1. All right. So as you go this way, it's approaching -1. Okay? So from the left, -2. From the right, it's -1. So what is the limit as x approaches this -1? Undefined, because it's approaching -2 from the left and -1 from the right. Okay? One-sided limits, though, you could say, if you're just looking at one side, you can say that limit would exist. But if you're saying the limit as it approaches one of these integers, no, it's not defined, okay? Does not exist. All right, let's see. And then 2, all right, so if you're on this side, same thing. As it approaches 2 from the left, then it's going this way. The y value is 1, so that limit's 1. As it approaches 2 from the right, it's approaching 2. Okay? 2.3. So 2.3 would be somewhere in here, right? So as x approaches 2.3, what's the limit from the left? 2. What's the limit from the right? 2. So what is the limit as x approaches 2.3? 2. Since it approaches the same thing from both sides, the actual limit exists. Okay? But the limit will not exist at any integer. Okay? Questions about that? All right, so C, for a given integer a, state the values of the limit as x approaches a from the left and from the right. Okay? So any integer that you pick, -3, -2, -1. From the left, it's going to be approaching what? So like at -2, right? It's approaching what from the left? -3. -1. If I approach -1 from the left, what's it approaching? -2. So it's approaching that integer minus 1. So I would say the limit as x approaches a from the left would be a minus 1. That'd be true for any integer. Okay? As it approaches it from the right, well, as I approach -1 from the right, the limit's -1. As I approach 1 from the right, it's approaching 1. So the limit as x approaches a from the right would just be a. Okay? Questions about that? In general, if a is not an integer, state the values of the limit as x approaches a from the left, a from the right. That would just be what? It'd be the greatest integer less than or equal to a. Depends on which side you're on. On this side, or this one. I mean, I think it would vary on either side, but you could just say the greatest integer less than or equal to a would be it. You can plug the value into the function. All right, so for what values of a does the limit not exist? That would be when a is an integer. Okay, that's when it does not exist. All right. Any questions about that? Now that function will pop up occasionally. All right, so there you go. All right, 2.3. So now we'll start techniques for computing limits.